everyone, my name is PHAKHAORN PHUYUTTHAKARIN, or you can also call me An. So today I'm going to present to you guys about nanorobot. Here's the structure. There is introductions, innovations, and method, challenge, and conclusions. So have you ever imagined that what if a tiny robot can really actually pass through your blood system for disease the disease for you? So here's mine. So it's a BioNanobot. It's intelligent nanorobot for target drug delivery. So as we know that cancer and cardiovascular disease are still a primary cause of death in worldwide. And the challenge with therapy on current therapy, which is chemotherapy, they didn't attract only the disease cell, but they also harm the healthy cells. So that's why the patients has harm effect, side effect, for example, hair loss, weakness immunity. Yeah. Alright, the objective, which is the core idea is BioNanoBot is an intelligent nanorobot that's designed for navigations in bloodstream, right? And also they can find detect the biomarker and release drug at exact area. The main goal is to enhance treatment safely and effectiveness. So I want to make patients to fearless about the treatment. It can also help the patient with about the mental health. So how are we gonna do that? There's two stages on right now, which is the first stage in the laboratories. The first one is nanorobot will go through our bodies, right? So we have to make from the biocompatible materials so it can be safety for us. Yeah, and the second one here is the detection and target drug release. So there will be a molecular sensor that strict with the nanorobot, and they will allows nanorobot to detect disease biomarker. Lab testing with glioma cells check targeting and drugs. The stage 2, which is computer stimulation. The computer stimulations, before testing them in the real patients, we use computer stimulation. This is creating virtual bloodstreams on the computers, where we can check if the nanorobot can move correctly, their flights for disease or not. Challenge and application. Of course, moving to the lab to clinics bring challenge, right? Potential immune response, difficulty to precise navigations inside the humanities. They have high potential costs, they strict safety validations requirement. But if we overcome this barrier, this will be really great for our future. BioNanoBot is not just a tiny robot in bodies. They represent the future of predictions medicines, treatment that is personalized, effortless, and safer for patients. One day, patients have no longer have to fear the hard side effect of drugs, because an invisible army of nanorobot will already be fighting the disease inside them. This innovations is I try to find a gap between a lot of research. So the gap, which is the first one is I try to is develop a biocompatible nanorobot with a molecular sensor that can be detect cancer biomarker precisely, solving the issues of limit accuracy. Second one is their movement and target like refined through computer stimulations of blood flow, improving navigation control before moving to a real trial. And the third one, which is visual safety assessments, predict science effect, and drug distribution in the advance. So all of that is project. So all of my project is it's just like conceptual, and is on the this project is like literal reviews. So it's just an idea for the future. Here's the research that support. Thank you for your attention.
네, 질문 있으신 거주해 주시기 바랍니다.
Thank you very much for the interesting talk. Do you think you can control the time frame that nanorobot stays in the body? Because we want to basically, I mean, after treatment, we want to remove this, right? So how do you think you can control the time that stays in the body?
Actually, I read the research of like their navigations, right? They say that like on this time, like current stage is on laboratories. They're trying to like make a code, like and there's like, do you know like what is it called? GPS, like a map for them. So it is actually hard because our body is like, there's a thing that we can't control, right? So I mean on this time, like on current stage, it is still like trying, they're still trying to figure it out.
Yes, sounds very interesting, but I have a couple of issues to ask you. First thing is, what is the energy source this robot is going to use? So biochemical energy or like a battery, or how these robots can, do all these functions?
Do you mean how they're gonna work in our body?
Right, the energy. How does this robot get energy? Like the battery or a biochemical energy?
There's a so basically in nanorobot there will be like a little chip that is always that like the people in lab and the real patients, the people in lab will control, and it's not like batteries, but it's the power that can be like it's like power bank. I'm not really sure what is it called, but it's just a small chip that it can work like 24 hours, like in the research.
So after a certain period of time, so all the power is running out, then this robot is going to be just dead.
Sorry?
After all the power is out,
what if it's
what's going to happen to these robots?
Actually, they said the doctor and the patients have to plan all like when we're gonna infect it inside our bodies. We have to plan, and we have to set batteries like a power bank in there to during the treatment, like and help doctor to therapy just in time before it's running out.
Okay. And also, how does the doctor going to administer this robot, like through the GI tract or to the vein?
Sorry, you mean how do they track?
How do these robots enter into your body, like through the GI tract or
infections?
Hmm?
Injections.
How do you
sorry.
inject it? Like through the vein, blood vessel?
It's like on the research on this time, they said it can be like inject to your bodies, but
Directly
I'm not pretty sure that how they're gonna like put it inside. I mean like with the chemical things. I'm really not sure, but I'm gonna research it about it later.